Ever wondered why, in a universe so vast, we still haven't encountered any signs of extraterrestrial life? Imagine, countless stars and planets out there, yet we seem to be alone. It's a question that has gripped the minds of many, sparking endless debates and theories. This conundrum, this puzzle that has baffled the greatest minds, from seasoned scientists to casual stargazers, is known by a particular name. This paradoxical question that intrigues scientists and non-scientists alike is what we call the Fermi Paradox. Remember to like this video and subscribe to the channel. Now, let's unravel the Fermi Paradox. The Fermi Paradox is a remarkable concept that has stumped scientists and thinkers alike for decades. It's named after the Italian-American physicist Enrico Fermi, a key architect of the nuclear age and a Nobel laureate. One fine day in the summer of 1950, while having lunch with colleagues, Fermi famously blurted out a question that still echoes through the halls of science. Where is everybody? This spontaneous question is the crux of what we now know as the Fermi Paradox. It's a conundrum that arises from a contradiction, a clash of two seemingly logical assumptions about our universe. On the one hand, we have the vastness of the cosmos with its billions of galaxies, each teeming with billions of stars. Many of these stars we know have planets orbiting them just like our sun. Given the sheer scale of the universe, it seems almost inevitable that there should be other civilizations out there, perhaps even advanced ones. Yet on the other hand, we've seen no signs of these civilizations, no radio signals, no spacecraft, no alien footprints on the moon, no evidence at all. Despite our best efforts, our universe seems eerily quiet, devoid of any other voices but our own. So, Fermi's question stands more puzzling than ever. Where is everybody? It's not just about aliens and UFOs, it's a question about our place in the universe, about our loneliness or lack thereof. It's a question that challenges our understanding of life itself, of its rarity or its abundance. In essence, the Fermi Paradox is a profound cosmic mystery, a riddle wrapped in the star-studded fabric of the universe itself. It's a paradox that tantalizes us, that compels us to look up at the night sky and wonder, are we alone? So the Fermi Paradox leaves us with the burning question, where is everybody? To fully understand the Fermi Paradox, we must first acquaint ourselves with the Drake equation. This equation, introduced by Frank Drake in the early 60s, is a scientific approach to estimate the number of civilizations in our galaxy with which we could potentially communicate. Let's dissect this fascinating equation to understand its various components. The first factor, the rate of star formation, represents the number of new stars born in our galaxy each year. These stars are the potential hosts for planets and thus life. Next, we have the fraction of those stars that have planetary systems. Thanks to advances in astronomy, we now know that this fraction is quite high, with most stars hosting at least one planet. The third factor is the number of planets per star that could potentially support life. This depends on a variety of conditions, such as the planet's distance from its star and its atmospheric composition. Then we have the fraction of those planets where life actually develops. This is one of the most uncertain factors in the equation, since it depends on the complex process of abiogenesis, or life originating from non-living matter. The next factor is the fraction of life that evolves into intelligent beings. Again, this is highly speculative, as we only have one data point, Earth. Moving on, we have the lifespan of a technologically communicative civilization. This is the length of time such a civilization can send out signals into space that we could detect. Finally, we sum all these factors to estimate the number of civilizations in our galaxy with which we could potentially communicate. It's important to note that the Drake equation doesn't provide an exact number. Instead, it gives us a way to contemplate the variables involved in the search for extraterrestrial intelligence, and depending on how optimistic or pessimistic we are about these variables, the equation can provide vastly different results. Despite the Drake equation suggesting a high probability of extraterrestrial civilizations, we're yet to make contact. This brings us back to the Fermi Paradox. The Fermi Paradox isn't without its potential solutions or explanations. Now let's delve into some of the most popular theories that attempt to answer this cosmic conundrum. First up, we have the zoo hypothesis. This solution posits that we are, in a sense, living in a cosmic zoo. Advanced extraterrestrial civilizations could very well exist, but they're consciously avoiding contact with us, perhaps to allow for our natural evolution and development, or to prevent us from self-destruction. Imagine for a moment being watched by galactic zookeepers, curious about our progress, yet hands-off in their approach. Next on our list is the rare Earth hypothesis. This proposes that the conditions necessary for intelligent life are incredibly rare in the universe. It's not just about being in the Goldilocks zone, that sweet spot, not too hot, not too cold for liquid water to exist. It's also about having a planet with a stable orbit, a protective magnetic field, the right chemical elements, and a host of other factors that make Earth, well, Earth. So while life might be possible elsewhere, the odds of it being intelligent life could be astronomically low. Then we come to the chilling concept of the Great Filter. This hypothesis suggests that at some point in the development of a civilization, there's a barrier or filter that is incredibly difficult to pass. This could be anything from a global catastrophe like nuclear war to the self-destruction that comes with advanced technology, or even a yet unknown challenge. Essentially, civilizations might be common, but they don't last long enough to make contact. Finally, there's the idea that we're just not listening properly, or that we're misinterpreting the signals. Maybe extraterrestrial civilizations are communicating in ways we can't yet comprehend or detect, or maybe they came and went during the billions of years before we even showed up. These solutions offer fascinating, albeit speculative, explanations for our cosmic solitude. But as we continue to peer into the depths of the cosmos, who knows what we might discover? After all, the universe is a vast, mysterious place, and our understanding of it is constantly evolving. But one thing is for certain: the quest to solve the Fermi Paradox continues to challenge and inspire us, reminding us of our humble place in the grand cosmic scheme. So, where does this leave us in our quest for extraterrestrial life? We've journeyed through the intriguing landscape of the Fermi Paradox, grappling with the perplexing silence in a cosmos teeming with potential for life. We've examined the Drake equation, a mathematical marvel that tantalizingly hints at the likelihood of intelligent civilizations beyond our own. Yet, as we've seen, possible solutions to the Fermi Paradox are as diverse and complex as the universe itself. From the idea that we might be alone to the thought that we might simply be too primitive to perceive advanced civilizations, the possibilities are vast and humbling. This paradox is not just a question about extraterrestrial life. It's a mirror reflecting our own existence, our yearning for connection, and our endless curiosity. Remember to like this video and subscribe to the channel. As we continue to gaze at the stars and question our place in the universe, the Fermi Paradox reminds us of the vast mysteries that still await our discovery.